All right, so we're diving into medical imaging AI today. And you sent over some research on RAD DINO, this new method for training AI to understand medical images. And I got to say, I'm pretty intrigued.
Yeah, it is a fascinating development. RAD DINO is really pushing the boundaries of what we can do with AI in healthcare, especially when it comes to analyzing these images.
Okay, so the big question I have is how does RAD DINO actually work? And why is it such a big deal? Like, what makes it different from what we've been doing before?
Well, the foundation of RAD DINO is actually in this technique called DINO, which stands for self-distillation with no labels. It's a self-supervised learning method that was originally developed for just general image recognition tasks.
Self-supervised learning. Okay,
Okay.
that sounds familiar. So it's like we're teaching AI without having to label all the data, right? Like letting it kind of figure things out on its own.
Yeah, exactly. So instead of relying on humans to label thousands and thousands of images, Dino learns by just comparing and contrasting different views of the same image, identifying those subtle differences and similarities.
So it's like a visual puzzle.
Right.
The AI has to kind of figure out how all the pieces fit together without being told what the final picture looks like.
Yeah, that's a great analogy. And what makes Dino so powerful is that it can learn these really complex visual representations without needing any text descriptions or labels. It's all about just the images themselves.
Okay, so that's Dino. But how does that relate to RAD Dino? How do we get from there to medical imaging?
Well, RAD Dino basically takes the principles of Dino and applies them to the specific challenges of medical imaging. So you can think of it as Dino, but, fine-tuned and optimized for working with X-rays and CT scans and all those other medical images.
So we're kind of taking this general purpose image recognition AI and we're giving it specialized training to be a medical imaging expert.
Exactly. And that's where it gets really interesting. Because you see, traditionally, AI models for medical imaging have relied heavily on text descriptions like radiology reports to learn and make predictions.
Right, because those reports have valuable information from the doctors about what they're seeing in the images. So it kind of makes sense to use that as training data, right?
It does. It does. But it also has its limitations. Relying solely on text can create a bottleneck. Radiology reports, while valuable, are often very brief, and they might not capture all of the subtle details that are actually present in the image itself.
So you're saying there's more information hidden in those images than what we're explicitly writing down in those reports.
Exactly. And that's where RAD DINO really shines. Because by learning directly from those images without relying on text, it can start to uncover hidden patterns and potentially even identify things that human radiologists might miss.
Okay, so instead of being limited by the words in a report, RAD DINO is learning to see the whole image,
Yeah.
more like a seasoned radiologist would.
Exactly. It's learning to analyze those textures, the shapes, and the subtle variations in density that are often crucial for making an accurate diagnosis.
Okay, that's starting to make sense to me. So walk me through this a little bit more. What's the architecture of RAD DINO? How does it actually process these medical images?
So RAD DINO uses this powerful architecture called a vision transformer, or VIT for short. You can think of it as a neural network that's specifically designed to understand visual information.
Okay, neural networks, yeah. Those are those things that are kind of loosely inspired by the human brain, right? All those interconnected nodes that process information.
Exactly. And vision transformers are particularly good at capturing these long-range relationships within an image, which is crucial for understanding the complex context of a medical scan.
So instead of just looking at individual pixels, it's kind of analyzing how all the different parts of the image relate to each other, like how the shape of a rib might be connected to the appearance of a lung lobe.
Precisely.
Yeah.
And that ability to kind of see the bigger picture combined with its training on these massive data sets of medical images allows RAD DINO to achieve some remarkable results.
Okay, I'm definitely intrigued. We've talked a lot about the why behind RAD DINO, but let's dive into the how a little bit more. How does it actually learn from these images without any of those text labels?
The key is those self-supervised learning techniques we talked about earlier. Specifically, RAD DINO utilizes something called masked image modeling and self-distillation.
Masked image modeling. I vaguely remember that from when we talked about Dino. It's like we're giving the AI a puzzle, right?
Yes. Imagine taking an X-ray image and then randomly masking out certain portions of it, like you're hiding parts of the lungs or the bones.
Yeah.
The AI's task is then to predict what's hidden behind those masks based on the surrounding context.
I like filling in the blanks in a picture. But instead of using our logic or reasoning, is using these complex visual patterns and relationships.
Exactly. And by doing this repeatedly with thousands of images, the AI starts to recognize those patterns And it develops a deep understanding of what a normal chest X-ray, for example, should look like.
Okay, that makes sense.
Yeah.
But what about self-distillation? How does that fit into this whole learning process?
So self-distillation is kind of like having the AI teach itself. It involves creating multiple versions, or students, of the same model, and having them learn from each other.
So it's like a group study session,
Yeah.
but instead of students sharing notes, it's different versions of the same AI sharing their knowledge.
Yeah, that's a great way to put it. Each student model sees a slightly different view or augmentation of the same image, and then they all compare their predictions. This process of kind of comparing and contrasting helps to refine their understanding and makes them more robust to variations in those images.
Okay, that's pretty clever. So by combining the masked image modeling with the self-distillation, RAD DINO is able to learn from images in a way that's much more nuanced and sophisticated than we've done before.
Exactly. It's pushing the boundaries of what we can do with self-supervised learning in medical imaging, and the results are pretty impressive.
All right, I'm hooked. Let's dive into those results. What can RAD DINO actually do? And how does it compare to those other methods that rely on those text descriptions?
Well, RAD DINO has been tested on a range of tasks, and it consistently either outperforms or matches those existing language-based models, even on tasks where you'd think that text training would give them a big advantage.
Wow, that's pretty remarkable. What kind of tasks are we talking about here?
Well, one of the key tasks is image classification, which is essentially training the AI to recognize different conditions or abnormalities in those medical images.
So like looking at a chest x-ray and saying, okay, this looks like pneumonia, or this could be a sign of heart disease.
Exactly. And the researchers tested RAD DINO on a data set of chest x-rays called VinDoctor CXR, which includes a really wide range of findings from, common conditions like lung nodules to more rare abnormalities.
Okay, and how did it perform? Was it able to accurately identify these different conditions?
It did. And what was impressive is that it actually outperformed other models that were trained on much larger data sets of text and images.
Wait, so it beat models that had more training data. That's surprising. What was the RAD DINO's secret weapon?
Well, the researchers attribute its success to a few key factors. First, RAD DINO's ability to handle high-resolution images is really crucial. It can pick up on subtle details that might be missed at lower resolutions.
So it's like having this high-definition view of the X-ray.
Yeah.
And it's able to see the nuances that other models just kind of blur over.
Exactly. And second, that masked image modeling objective we talked about, that whole process of filling in the missing pieces of an image, well, it turns out that's really effective for capturing the textual information, and that local information that's often crucial for making an accurate classification.
So it's not just about recognizing the overall shape of a lung, but it's also about understanding those subtle variations in density and texture that might actually indicate a problem.
Precisely. And this becomes even more evident when we look at another task, semantic segmentation.
Semantic segmentation. I
Sure.
feel like we've talked about that before. That's about identifying different regions or structures within an image, right?
You got it. It's like teaching the AI to draw outlines around specific areas of interest, like the lungs, the heart, or even a tumor.
So it's not just saying there's a tumor somewhere in this image, it's actually pinpointing its exact location and boundaries.
Exactly. And the researchers found that RAD DINO was really good at this task as well. They used it to segment chest x-rays into meaningful regions, like lung zones, ribs, and even pneumothorax, which is a collapsed lung.
Wow, that's amazing. So it's not just identifying what's in the image, but it's understanding where everything is located and how it relates to all those other structures.
Right. And this ability to precisely segment images has huge implications for diagnosis, treatment planning, and even surgical guidance.
It's like having an AI assistant that can highlight those areas of concern and give doctors this really detailed understanding of the patient's anatomy.
And to make things even more interesting, the researchers actually experimented with different decoder heads, which are essentially the parts of the model that interpret the features extracted by RAD DINO.
Decoder heads. It sounds like we're building a Frankensteinian AI monster here.
Can see why you'd say that.
Yeah.
But think of it like giving RAD DINO different sets of tools for different tasks. So they used a simple lineal decoder, a more complex VT-det decoder, and even UPRNet, which is often used in those state-of-the-art segmentation models.
So they were really putting RAD DINO through its paces, testing it with different levels of complexity.
Exactly. And what's remarkable is that even with the simplest decoder, RAD DINO's performance was competitive with, and in many cases superior to, models that were specifically designed for segmentation.
So it's like showing up to a carpentry competition
Yeah.
with a basic hammer and nails and still outperforming the guys with all the fancy power tools.
That's a great way to put it. And when they used those more advanced decoders,
Yeah.
the results were even more impressive, achieving near state-of-the-art performance.
So it sounds like RAD DINO is not only this really powerful feature extractor, but it's incredibly adaptable as well. It can work with a variety of tools to get the job done.
Exactly. And that adaptability is one of the reasons why researchers believe RAD DINO has such huge potential. It could be fine-tuned and specialized for a whole range of medical imaging applications.
Okay, this is all incredibly impressive. But you mentioned earlier that RAD DINO could potentially even identify things that human radiologists might miss. Can you give me a specific example of that? What are we talking about here?
Well, one of the most surprising findings of this research was RAD DINO's ability to predict patient metadata from the images alone.
Metadata. You mean information about the patient,
Yeah.
like their age or their medical history?
Exactly. So RAD DINO was able to predict things like a patient's sex, their age, their weight, and even their BMI, just from looking at their chest x-ray.
Wait, seriously? How's that even possible? I mean, that information isn't explicitly encoded in the images, is it?
It's not, and that's what makes this finding so remarkable. It suggests that RAD DINO is picking up on these really subtle visual cues that are correlated with those characteristics, things that even experienced radiologists might not consciously notice.
So it's like RAD DINO is learning to see connections that we humans haven't even made yet. It's almost like a sixth sense.
That's a great way to put it. And what's interesting is that language-based models like CLAP really struggle with this task. They just can't seem to extract that metadata from the images.
So that really highlights the power of RAD DINO's visual understanding. It's seeing things that other models are just missing completely.
Then that ability to extract hidden knowledge from images has some potentially fascinating implications for personalized medicine. Imagine being able to tailor treatments or predict risk factors based on subtle visual features that we've just been overlooking.
That's taking personalized medicine to a whole new level. It's like we're reading between the lines of the X-ray to uncover this hidden information about the patient.
Precisely. And this ability to unlock that hidden knowledge is one of the reasons why RAD DINO is generating so much excitement. It's not just about doing what we already do, but better. It's about opening up new frontiers in medical diagnosis and treatment.
This is all pretty mind-blowing. But if RAD DINO is so good at understanding these medical images, why isn't it being used in hospitals already? What are the hurdles?
Well, like with any new medical technology, there are always these hurdles you have to overcome before it can be widely adopted.
Okay, so what are some of the biggest challenges facing RAD DINO right now?
I think validation is a big one. Before we can trust an AI model to make decisions about patient care, we really need to rigorously test it on large, diverse populations to make sure that it's accurate and reliable in those real-world scenarios.
Right, you can't just assume that what worked in a research lab is going to work in every hospital and with every patient.
Exactly. And then there's also the issue of integration. How do you seamlessly incorporate these AI tools into the existing clinical workflows? How do you make sure that doctors and radiologists can trust and use these systems effectively?
Yeah, it's about more than just the technology itself. It's about potentially changing how we approach diagnosis and treatment. And that takes time and careful planning and a lot of collaboration between the researchers, the clinicians, and the technology developers.
Absolutely. And then you also have the practical considerations of cost and implementation. These AI models require very powerful computing resources to run, and not every hospital or clinic has that infrastructure in place to support them.
Okay, so we've got technical challenges, logistical challenges, and financial challenges to overcome. But it sounds like the potential benefits are huge, especially if RAD DINO can help us diagnose diseases earlier, personalize treatments, and maybe even uncover new medical insights that we've been missing all along.
I completely agree. And I think it's important to remember that this research is still in its early stages. RAD DINO is really just one example of the incredible progress that's being made in medical imaging AI. And I'm optimistic that these technologies will continue to evolve and become more accessible over time.
So we're not quite at the point where AI is going to replace radiologists altogether. But it sounds like we're moving in a direction where AI can be a really powerful tool to assist doctors and improve patient care.
That's a great way to put it. I think the future of medical imaging is one where humans and AI work together, each kind of leveraging their own strengths to achieve better outcomes.
This whole deep dive has been incredibly fascinating. But I have one more question before we wrap things up. We've talked a lot about chest x-rays, but can RAD DINO be applied to other types of medical images as well?
That's a great question. And the answer is yes, absolutely. While the research we've discussed today has focused primarily on chest x-rays, the principles behind RAD DINO can be applied to a wide range of medical images, including CT scans, MRIs, ultrasounds, and even those histopathology slides.
So the potential applications are pretty vast. Could we see RAD DINO being used to diagnose everything from cancer to heart disease to neurological disorders?
It's definitely possible. The key is having access to those large, high-quality data sets of images for training and validation. But as those data sets become more readily available, I think we'll see RAD DINO and similar AI models being applied to a growing number of medical specialties.
This is all incredibly exciting and a little bit mind-boggling, to be honest.
Hmm.
It feels like we're on the cusp of a major revolution in healthcare, where AI is going to play an increasingly important role in how we diagnose and treat diseases.
Yeah, I share your enthusiasm. It's an incredibly dynamic field, and the progress that's being made is truly remarkable. I can't wait to see what the future holds for medical imaging AI and the positive impact it will have on patients' lives.
Well, this deep dive has definitely given me a lot to think about, and I'm sure our listeners are feeling the same way. It's been an incredible journey into the world of RAD DINO and the transformative potential of AI in healthcare.
It's been a pleasure discussing this with you. I always enjoy exploring these cutting-edge topics and sharing these insights with our audience.
And to our listeners, thank you for joining us on this deep dive. We encourage you to stay curious, keep asking questions, and be a part of this exciting journey as AI continues to reshape the landscape of medicine.
That's a great question, and it's something that a lot of people are probably wondering about. What's the holdup? Why isn't this revolutionary technology already out there helping doctors and patients?
Yeah, what are some of the biggest challenges facing RAD DINO right now?
Well, I think validation is a big one. Before we can trust an AI to make decisions about patient care, we really need to rigorously test it on large, diverse populations to make sure it's accurate and reliable in real-world scenarios.
You can't just assume that what worked in a research setting is going to translate to every hospital and every patient.
Exactly. And then there's also the issue of integration. How do you seamlessly incorporate these AI tools into the existing clinical workflows? How do you make sure that doctors and radiologists can actually trust and use these systems effectively?
Yeah, it's about more than just the technology itself. It's about changing how we approach diagnosis and treatment, and that takes time and careful planning and a lot of collaboration between the researchers and the clinicians and the technology developers.
Absolutely. And then you also have those practical considerations, cost and implementation. These AI models require very powerful computing resources to run, and not every hospital or clinic has the infrastructure in place to support them.
So we've got technical challenges, logistical challenges, and financial challenges to overcome. But it sounds like the potential benefits are huge, especially if RAD DINO can help us diagnose diseases, earlier personalized treatments, and maybe even uncover new medical insights that we've been missing all along.
I completely agree, and I think it's important to remember that this research is still in its early stages. RAD DINO is really just one example of the incredible progress that's being made in medical imaging AI, and I'm optimistic that these technologies will continue to evolve and become more accessible over time.
So it sounds like we're not quite at the point where AI is going to replace radiologists altogether, but we're moving in a direction where AI can be this really powerful tool to assist doctors and improve patient care.
That's a great way to put it. I think the future of medical imaging is one where humans and AI are working together, kind of leveraging each other's strengths to achieve better outcomes for everyone.
Well, this has been an incredibly fascinating deep dive, and I'm sure our listeners have learned a ton about RAD DINO and the potential of AI in healthcare.
It's been a pleasure discussing this with you. It's always fun to explore these cutting-edge topics and share those insights with our audience.
And to our listeners, thank you so much for joining us. We encourage you to stay curious, keep asking questions, and be a part of this exciting journey as AI continues to reshape the landscape of medicine.